Okay, we're ready to go? All right. So good morning, good afternoon, and good evening, everyone, depending on where you are around the world. So thank you for joining us today. This is Naomi Chen, the product line manager at Acton Corporation, and covering our brand business Edgecore network. I'm based in the Bay Area, United States. So feel free to ping me or drop me a message if you want to have a coffee chat, anything. For those of you who joined our webinar series for the first time of this year, welcome to. We have partnered with the industry leaders to host these sessions specifically to discuss what we call the ecosystem of choice. So I'm sure everyone on this call here is because you're interested in having more flexibility in your network or the IT infrastructure. So today I'm joined by Sandy Ronan, the Director of AI Networking from DriveNets, to explore the various approaches to creating high performance, high scale AI compatible networks. Before we dive into the details, I want to set the stage for how we're bringing these pieces together. So for those of you who have been in the industry for long, you have likely noticed the 10 to 15 years cycle that redefined our lives from PC to internet to the cloud. And now I think we can all agree that today in 2026, AI is no longer just a buzzword. We're actively weaving into this very fabric of our global infrastructure. In this new era, the network is no longer just a support system, I believe, because with the scale up and scale out, all the things, it's one of the, it's kind of the heart of this engine now. And this is where this ecosystem of choice becomes critical. So at Edgecore, we believe that open networking or network disaggregation is much more than just a technical term. It's a freedom to choose. It allows you to pick the best in class hardware, hopefully from us, the operating systems and the management layers for your network. And you can optimize every piece of this equation to build a solution that is resilient and as is scalable. So why does choice matter? Is there still a benefit to vertically integrated stack from a single vendor? So absolutely, but we have realized that when you disaggregate it properly, correctly, so you unlock the tremendous value. You can bring together the best chips, the best hardware, and the best operating environment, all that thing. When you do it correctly, this whole process significantly reduced your total cost of ownership. And you only pay the features you actually need while gaining the full control over your supply chain and the product lifecycle. Also, that as you need change, you don't have to re-architect your entire network. You can simply swap a specific pieces that you need, maintaining the operational consistency because you are the one defining this architecture. We also see a massive boost in innovation speed. Let's just using LLM as an example. The capacity of AI agents has improved dramatically because multiple vendors are innovating simultaneously. So when using this as an example, when focused teams put technology together without the burden of legacy baggage, the rate of innovation doubles, triples, or even quadruples. So have we done disaggregation before? Is that a distribution just a new term? No, we have done it in the IT for years, So back in the day, everything is IBM in the data center, and now we're naturally use storage from one vendor, servers, software from many different vendors. So this is that even with a vertical integration, the entire market ultimately shifts toward a open ecosystems. So which is why this interoperability becomes so critical. We have proven we can bring multiple vendors together. And the only challenge has been how well they can stitch together. And that is exactly why this ecosystem solves this problem. Let's look at just purely from the number perspective and use Sonic as a primary placeholder for this discussion, because Sonic is kind of a symbol for the open networking, right? So we have seen this from Del Rao predict that 10% of the market is disaggregated in around 2026, which is now, and the target expected to hit 20% within a year in 2027. So we're seeing this rapid adoption rate in the data center, and so you're not alone in this journey. And so to make this work, we look at 3 layers of network disaggregation. So at the very top layer is your management and orchestration. At the center layer is the network operating system, is the NOS. And the bottom layer, this is where Edgecore spend a lot of our time, is the hardware itself. So we work closely with all our partners to ensure their solutions play perfectly with our hardware. You don't have to make a science project out of this. You can simply deploy it and start receiving the value. So this whole ecosystem is tested, assured, and ready to be stitched together for your specific application. We're here to help you to navigate this transition, not just for the day zero of deployment, but for the long-term life cycle and operational consistency that you need to thrive. So I think this is a stage, and let's explore how we can build your AI infrastructure together. So our speak Sunny serves as a director of AI networking at DriveNets. Will take us to learn how the DriveNets operating systems running on Edgecore networks switching platform can deliver the AI you want at the performance and the budget you need. So Sammy, that's back to
Thank you
you.
very much, Naomi. I will share the presentation in a second. Okay, so again, thank you very much, Naomi. And as you mentioned, I'm Sunny from DriveNets, and today we'll talk a little bit about building the perfect fabric for AI. Before I start, I want to share a funny fact today. When I told my daughter that I'm doing a webinar, she was asking what it's about. So I said about AI fabric. She said, what does it mean? And when I said backend, suddenly her eyes were lit up. She said, oh, backend, I know about backend. So backend is like Roger Federer one-hand backend. I said, no, okay, it's good that you know about it, but it's a totally different story. Although I think same as Federer, I think our backend solution is one of the best. And again, it was funny to me that backend is something that was familiar for her. So the agenda today, I'm going to talk a little bit about DriveNets, in case you're not familiar with DriveNets, some of the challenges of the AI era from the networking and the cluster perspective, dive into the different options of networking that exist today in the industry, and then more detailed about DriveNet solution on all the layers, similar to Naomi, 3 layers of networking, about the hardware, the operating system, and the orchestration. I think we have a full solution that we would like to present and show you the capabilities. I will also show some use cases of key customers and the challenges they had, and the reason they chose DriveNets. And in the end, we'll have a Q&A session. So a little bit about DriveNets. So DriveNets was founded in 2016. We are celebrating 10 years. The last year, we had massive growth, both in revenue and also in employment number. So we grew to more than 650 people. Most of them, more than 80% are R&D. We are cash flow positive. We're still a private company. And historically, we have huge success. We started with offering to service providers routing solution for their networking. And today, we are part of AT&T core network. Most of their core network is running through DriveNets. Same with Comcast. And we have other customers around the globe in Europe, in Asia, that all of them are using DriveNets technology for different part of their network. But again, this is the service provider network. What we want to talk about today, we have a different product line, our DriveNets AI Fabric product line. In this product line, we have success with hyperscaler, with some LLM vendors, huge LLM vendors. The most typical customer will be a neocloud, a new provider of AI services, and large enterprises that are using AI. Any customer who is building on-prem AI cluster would need some kind of networking solution. From partnership point of view, we are partnering with multiple leaders in the industry, different optic vendors, ODMs, as Acton and Edgecore, some IC vendors, mainly Broadcom, that we use the technology, but not only. And from standard point of view, we are actively participating and influencing on the OCP, the Open Compute Project, the TIP, the Telecom Infra Project, and the UEC, the Ultra Ethernet Alliance. And through them, we are preaching for Ethernet and promoting the open solution. So from product line point of view, as I mentioned, we have two product lines, the service provider product line that there we are offering a full network transformation, moving from legacy networks, from multiple networks to a single network. We are escorting the service provider through this process. But again, I don't want to spend too much time on that. You can read it in our website. Today's focus is about our AI Fabric solution, where we offer not only networking solution, but a full stack solution, different layer that are more cluster focused, because we understood that the customer don't ask for network. They want a fully operating cluster and very efficient and high performance cluster. Basically, our solution is the highest performance. I will show you some results. We are offering end-to-end solution to our customer. And as you can look at it, is a turnkey alternative to NVIDIA solution. When NVIDIA are coming and offering a full solution, today at DriveNets, we are trying to offer customers a full key solution based on different GPUs. I'll touch it in a second. One of the unique points is that we have our own operating system that can serve different application, different requirements, different networking architectures. All of them are coming from with the same support of a single operating system. And again, a very proven operating system, actually the same one that is used in the service provider for the last 10 years, is serving our AI infrastructure as well. So a full stack solution, how does it look? Let's look on the bottom. You can see the network platforms. These are the switches and the routers that, again, from our AI solution are coming from Edgecore Acton, both the routers and the switches that we are using. On top of that, you can see the backend and front-end application, the different scale up, scale out, scale across to remote location and front end. On top of that, the operating system, and we have the ACO, the AI Cluster Orchestrator. This is actually a tool that I will present in details that can provide additional services on top of just network, but brings the unification of the network and the cluster and the GPU's performance together. We also have the DIS, the DriveNet Infrastructure Services. This is a team of experts that can help customers on the different stages from the planning, installation, and up to performance, benchmarking, and handover and training that I will touch in details. So when we look at the challenges, and again, let's look at the diagram, what I've seen in the last 2 years and talking to customers, most customers would install AI, will go to NVIDIA, and will buy a full solution from NVIDIA. It's safe, it's proven, and it's working. So that's the good choice. AI is complicated. You are not really familiar with it. And that will be a very safe option to choose from. And then you will get the NVIDIA solution. And from networking, there is the NVIDIA InfiniBand, which again, it's a proprietary solution sold by NVIDIA. So that's the first step. And then customers, they start to see some of the challenges of InfiniBand. And if they want to move to something else, they have some challenges, right? First of all, it's performance. They want to make sure that if they move to a different solution, it still brings them the InfiniBand level performance. The job completion time, the latency, the fact that it's lossless, the RDMA functionality, GPU utilization in the end. So they want to make sure that if they move to something else, it needs to have InfiniBand level performance. They actually have issues with the vendor lock. When you buy InfiniBand, you are locked to NVIDIA. The lead time, you cannot really control it. If you don't have equipment, you need to wait for it. You don't have any other option to buy it from someone else. So actually, you have a very strong lock on the GPUs, on the NICs, on the switches themselves. So if you want to move to something else, you don't want to move to another vendor lock, moving from NVIDIA to other companies, let's say networking like Cisco or Arista, that you have a new vendor lock that you need to buy from them. The switches, it's a monolithic solution. The hardware and the software and the NICs and everything needs to come from them, and there are different licensing options. The deployment today with InfiniBand, it's complicated. If you're moving to another version of Ethernet, which is also complicated and need a very extensive configuration in the installation, that's also a challenge that they want to overcome. They want to move to Ethernet, but they want it to be easy to deploy and easy to manage. Another challenge comes from the application. When they are building a cluster, what they realize, it's not being used by one team or by one customer. It's used by different teams or different customers if it's a new cloud, a cloud provider. So they want to make sure there is a good tenant isolation without any penalty or overhead. So that's also a challenge they need to meet. Cross-site connectivity, moving to a different location if you have some limitation on the power, for example. I think this is the main challenge that they have. They don't have enough power in a data center to build the AI cluster they would like. So they are building it in two different geographical locations. So they need to connect those locations and still keep the high performance, still keep the network as lossless. So this is also a challenge. They are looking into a good solution. And in the end of the day, cost is also a major player. And when you buy InfiniBand, you pay the premium. Well, customers said, okay, so I pay the premium once, but then I have the yearly maintenance contract, which is 20% of the initial cost. So the initial cost was very high, and now the maintenance is also very high. So I want to get rid of that. It's something we would like, to move to a more attractive, more cost-effective solution. So what are the alternatives? Again, we talked about the InfiniBand. InfiniBand is a very good performance. It's scalable. It's efficient. Again, NVIDIA is doing a great job on that. But when you look on the disadvantages, it's proprietary. Everything needs to come from NVIDIA. The flexibility is limited. It's tailored to a specific application, specific workload. When you need to make changes in your workload, you need NVIDIA to come over and educate you on the configuration. And it's complex. Every organization, they have good IT people that are familiar with Ethernet. But InfiniBand is something you need to learn, and you need to be an expert on InfiniBand. And a lot of enterprises don't have this type of expertise. And building an InfiniBand team of experts, it's not a very wise thing to do on the long run. So what are the alternatives when moving to Ethernet? Everybody is convinced that moving to Ethernet, even NVIDIA are moving to Ethernet, right? So they are part of the Ultra Ethernet consortium, and they have an Ethernet-based product line. And again, as it looks like, InfiniBand is in a sunset mode, and there will be no major releases after this year on InfiniBand. So everybody is moving to Ethernet. When you look on Ethernet, you can have a single chassis solution that has more than 500 ports on the chassis of 800 gig. So it can be very efficient. The performance will be good as long as you are within one chassis, because you have the backplane, it's non-blocking architecture, but it's limited. It's limited to 570 ports. So if you want to move more and grow your network, you want to scale to a higher number, then you have an issue in your block. And again, it's still proprietary. You buy this chassis from a specific vendor. It's a monolithic solution. Everything comes from this vendor. So chassis is not a good solution when you want to scale. And even today, when customers are starting with 256 GPUs, it's obvious that they will need more, and the chassis will block them with scalability. The other solution is Ethernet cloth. It's a leaf spine architecture that you have two switches, and then the deployment is easy. It's very scalable. You have high radix switches that you can have many ports. You can grow. The drawback, major one, is performance. This is Ethernet. Normal Ethernet was not built for AI. It's a lossy technology. Ethernet is built on losses in the network, which is very good for internet users, for mail users, but it's not good fit for AI. So the efficiency of the workload is very low, and that's for it is not majorly used. And we will show you some numbers that customer evaluated the standard Ethernet, and again, the performance is totally unacceptable. And then the next evolution of Ethernet is endpoint scheduling using smart NIC. It's a congestion control Ethernet to make the network, the Ethernet network, a bit smarter. And you will use at the edges smart NICs that they will actually manage all the networking itself and make sure they are reacting in case of congestion. So the deployment is easy. It's still scalable. But the network performance is not there. Instead of avoiding congestion, you actually manage congestion. When congestion happens, then the NICs and the network is reacting. So the performance will not meet InfiniBand level. According to UEC, even that this is part of UEC as well, it's mentioned as sufficient performance. And in the end of the day, you need to use those smart NICs. They are very power hungry, very expensive, and it's complex to manage it. You need to deal with all those different buffers and ECN and PFCs, and to try to manage the buffer according to different workloads. So again, it might be a good solution in specific cases, but in the end of the day, it's not a good generic solution. And if you want to have InfiniBand level performance, you need to move to the next step. The next step is, as we look at it, the smartest option of Ethernet, the highest performance Ethernet for AI, which is scheduled fabric. In this case, the fabric itself is scheduled and is a smart fabric. So the network itself is smart. It's a non-proprietary solution. You can use different vendors for the hardware. You can use different vendors for the software. It's flexible, it's scalable. The efficiency is very high. The network performance is high, and I will dive into more details to explain why the network performance is high. The deployment is very simple, again, because the network itself is handling all the congestion and making sure they don't happen. You don't need to configure different buffers to manage. You don't need any telemetry. The fabric itself is doing the smart part. So in the end of the day, how it will look, instead of using the InfiniBand for the backend solution, connecting the GPUs and standard Ethernet for storage, you can unify the backend solution and the storage networking into one Ethernet that will be a high performance network. Not only the GPU will enjoy it, also the storage will enjoy it. So how do we do that, right? So how do we turn the standard Ethernet into a lossless, predictable network? So if you look on the diagram itself, you can see it's still a leaf spine technology. There is the leaf, the NCP, the packet forwarder, and the spine is the fabric switch. And then the connectivity to the GPUs and the storage is done, can be 200, 400, 800 gig, and soon 1.6. And the fabric itself is doing, if we look on the bottom 3 points, cell spraying. This is one of the 3 major building blocks. Cell spraying, meaning the network itself will take the packets coming into the network and will cut them into small cells and will distribute the cells across the entire fabric. So from one leaf, the cells will be sent to all fabrics, and from the fabrics, it will go to the destination leaf. That makes sure that there is no unbalanced connectivity in the network, meaning we cannot have a situation that one link is 80% loaded and the other one is just 20%, because at all time, the network will be evenly loaded. So all the connection will have 60% or 80% or whatever, because everyone is cut into small cells and the cells are spread evenly. So this means we get perfect load balancing without any need to do any configuration. So it's coming out of the box. The second point is the credit scheduling, receiver-based credit, meaning the receiver leaf is providing credit to the sender, making sure that if you send me data, I can handle it and I have enough bandwidth and enough capacity. So the known issue of incast, that suddenly one destination gets more than 800 gig, will not happen because it's credit-based, actually similar to InfiniBand, but based in Ethernet. So this is the second point that makes the network lossless. And the third one is the ingress VOQ, virtual output queues. That means that we have multiple virtual output queues in each leaf router, and then different GPUs or different tenants will be isolated, meaning one will have a certain VOQ, the other one will have a different VOQ. So if one is starting to load the leaf router, it will not block the others. So you have separation, isolation, strong isolation between tenant, and this will make sure that you are avoiding what's called the noisy neighbor phenomena, when one user is using more bandwidth that is entitled and actually interfering to all other users. So with these multiple VOQs, we actually totally eliminate the noisy neighborhood issue. So just to summarize that from technology point of view, in case it's interesting. So again, we are talking about the Edgecore boxes. From IC's point of view, we are using here the Broadcom Jericho 3 and Ramon 3 ICs that we are using them in the leaf and in the spine. Another point that is provided by the Broadcom hardware itself is the third point in how it works, the fast failover, the fact that the network itself in a hardware base would know that there is a failure in one of the links and immediately will update the entire cluster that this link is down and all the traffic will go to other links. So this is done in microseconds because it's being detected in the hardware, and you don't need to have the upper layer or the upper application layer to detect that and to react and to implement different protocols and different algorithms to make sure, and then it takes much more time. And during that time, you're actually losing data, and that's influencing the job completion time. So this is one of the benefits we are getting from using Broadcom ICs. So in the end of the day, when you are using Fabric Schedule Ethernet, customer will get predictable performance. You can plan for workloads, and then you'll get very high job completion time, very good job completion time at high scale. The deployment is very fast. You don't need to do sophisticated tuning. And of course, you can support multi-tenancy, which became a major issue recently. So we also have some kind of results that we compared. These results were measured, DriveNet results were measured in a live production cluster installed in Europe, and the measurement were done by a third party. And you can see the DriveNet result in blue. As I mentioned in the beginning, our customer goal is to have InfiniBand level performance. So if you can be in the same level of InfiniBand, that will be amazing. Ethernet with the same level of InfiniBand. But what we've seen that you can see here in the graph will show you on the left side the bus bandwidth. This is the throughput of the entire cluster. And on the bottom, you see different nickel message sizes. This test was done on NVIDIA GPUs. And when you are using the DriveNet FSC, you can see that our results are better. And again, 6% is the average when you look on the entire different packet sizes that are being used. Traditional Ethernet, of course, will have very low performance, again, because of the losses. And NVIDIA Spectrum X is a bit lower than InfiniBand, and still InfiniBand, we are showing that we can have better performance than InfiniBand all across the packet size. Here it's more detailed results showing DriveNets versus InfiniBand. And again, this is not the average. You can look on different communications, and you can see that all reduced, for example, we are 2% better. And again, the goal is to be at least on par with InfiniBand, and you can see that we are even better than that. Okay, so this is the results. When we look on the cooperation, when we look on the cooperation with Edgecore, so on the hardware point of view, from DriveNet's point of view, we are using routers and switches. The leaf itself, the DriveNet 5000 series, and the spine is the 9000 one, based on Jericho, as I mentioned. And we have two flavors. One is the standard leaf, and the other one is with HBM, with high bandwidth memory that is being used when you have scale across. When we need to move to a different geographical location, then you need better buffering to make sure you keep the lossless functionality when you have long distance connections. From switch itself, these are two U boxes, 30.4 terabytes, 18 ports going to the GPUs, 20 ports going to the fabric on both. And the fabric itself, it's a beast. It's using two Ramon ICs with total throughput of 102.4 terabytes with 128 ports of 800 gigabits. So we are coming to the additional layer that DriveNet is offering, the ACO. And this is automated end-to-end infrastructure orchestration services that helps the customer in the planning deployment stage, in the validation, and the operation stages. All of that is coming in an automated tool. In the end of the day, we would like our customer to have simple process, error-free, and get the highest utilization out of the hardware that they have acquired. So when we look into more details, first of all, this is one tool that we have, the Fabric Planner, that really helps. We have validated topologies that we have tested in-house of the networking part. So the customer will come and say, I'm using AMD, or I'm using NVIDIA, which type of GPUs, how many GPUs, what is the architecture I would like to use, if it's top of rack or top of rack optimization or rail optimization. And you will choose the different cabling you would like to use, optical cabling or duct cabling. And in the end of the day, we'll get a diagram, an architecture that is pre-validated with the BOM. So everything can be fast and no mistakes. and a lot of confidence because it was pre-tested. So this is the planning stage. After the planning stage, yeah. After the planning stage, we have the provisioning engine tool. This is part of our ACO. This actually brings end-to-end automatic cluster configuration. So it will help the customer to do the bring up, to deploy the required drivers, even in the servers, right? If there is a specific workload you would like to use, specific parameters you would like to optimize, the network need to be optimized according to the customer requirement. So we will do the cluster bring up, we'll do the smart topology discovery, meaning you will take the list of leaves and spines, what are the IP address, and then all the configuration will be downloaded to the device. And in the end of the day, it's a zero-touch provisioning. Everything is automated, very fast. I'll show you an example. This is an example, some screenshots I took from the tool. On the left side, you see the input, you see the IP addresses and the planned location, if it's a leaf, in which rail this device sits, and then you push off a button, all the configuration, all the parameters are being downloaded to the entire cluster. It can be tens or hundreds of switches, whatever, and you get it in no time. The second tool that we have in the ACO is the benchmark engine, and this is very important. This goes beyond the networking. We have different tools that run within stages. For example, the RDMA runner that will be testing the physical network. That will be testing the physical network and will verify that every NIC, for example, is being used and optimized. If it's a 400 gig NIC, that you'll get at least 97, 98% throughput on the NIC. Then we have the collective sweeper that will look on the nickel or the RICL performance and will optimize the network according to the customer requirements. There are optimization if it's a training workload or inference workload. And in the end of the day, there is the top 500 benchmark if a customer would like to know his cluster performance compared to the top 500. This tool is supposed to be used when you deploy a new cluster, when you onboard new tenants, and you want to make sure that you keep the utilization and performance, and periodical checkups. And the third part of the ACO is the day-end management. The tool that actually collects telemetry will show you the life cycle. And again, it's not only on the networking, and also on the GPU itself, what is the utilization percentage, the terminals of the network. And in the end of the day, this is the day-to-day management tool that, again, based on our 10 years of experience, it is a very sophisticated and simple to use tool with a lot of functionality. The DIS team, as I mentioned before, is the one that can help customer from the design phase to the installation, the record stack, the configuration, validation, benchmarking, and in the end of the day, enablement and training. All of these functionalities and support are part of our offering that customers are getting, and actually very happy with the results. I gave you a couple of examples of the results of the DIS team. This is, for example, a customer using AMD, and they wanted to have to squeeze the performance out of their AMD for any inference cluster. And what we did, we started with a single node, just with 8 ports, and we optimized the drivers, the operating system parameters, the BIOS configuration. And the parameter you see here is the concurrency, the requirements, how many users in concurrent are using the cluster, and what is the TTFT, the time to first token. So when they wanted to have a lower time to first token, it will be better. And as you can see, the blue one is the DriveNets solution compared to an industry standard solution that used with AMD. And again, this is before the networking part. This is on the single server. The second stage was when we looked on a multi-node. Then the network comes into play. So on top of the GPU optimization, on the server optimization, we did the networking optimization, and we used the specific parameters on the network, again, based on our knowledge, on the tools. They are able to download the right configuration for the specific workload. And in the end of the day, if you look on an average, you get 15% improvement in the TTFT compared to the industry standard. Okay, from a case study point of view, again, I will not spend much time on that. If you're interested, you can look at it on our website. We have different type of customers, enterprise customer. This is a biochemistry research institute. They came to us, they said, our first cluster was NVIDIA, InfiniBand. We want to move to Ethernet. They tested different vendors, and they decided that our solution was the best. They liked the performance and the fact that we have unified fabric and multi-site connectivity. This is something they plan to do. From hyperscaler point of view and LLM, again, here I gave one example, but basically, again, we did a POC with ByteDance, and they tested different versions of Ethernet, and then the smart NIC Ethernet and the FSE, and they saw that they are getting 30% improvement in job completion time compared to any other Ethernet option. So this is the reason they chose DriveNets. Last one is a NeoCloud. So this NeoCloud, again, we met them last year, and again, the project was very fast. They wanted to use Ethernet. They chose standard Ethernet. They saw that the performance is not there. So immediately we did a POC. They started with a single location in Europe, and now they are moving to multiple data centers in Europe this year. This is the way it looked. And again, just to emphasize that you can see both the GPUs on the left side and the storage is part of the same network, and they were very happy with their results. I have a short testimonial, a 1.5-minute video from the customer. This is Tom, their CTO. I will let you listen to his testimonial for a minute.
Hi, I'm Tom Sanfilippo. I'm the CTO at White Fiber. We're an AI cloud company focused on performance and scalability for AI applications of any size. One of our biggest challenges has been building GPU clusters around Ethernet technology, but without the potential bottlenecks of mixing workloads from multiple customers simultaneously. In the past, we would build GPU clusters using separate networks for storage and compute. This makes it challenging to build very large networks. It increases the network complexity. It increases the number of components we have to use. DriveNets Fabric Scheduled Ethernet has allowed us to converge our GPU and storage workloads onto one fabric. This is something we couldn't do with other technologies. It's provided great efficiency in terms of network throughput. It enables us to support multi-tenancy better by providing isolation and fair queuing across the entire network infrastructure. We are looking to expand clusters using the DriveNets technology and apply it in new areas as well, including cross-data center connectivity, cluster-to-cluster connectivity, and building larger superclusters. The DriveNets infrastructure services team was also a really big help in getting our POC built rapidly and proving out the technology for us to make the decision to move to the next step and bring that environment into production. They did an amazing job. It's been a real pleasure working with them.
Yeah, so again, it was an amazing project and it's ongoing activity with White Fiber. I would like also to touch in a few seconds about some of the key use cases where the technology shines and gives unique advantages compared to any other Ethernet, multi-tenancy, unified fabric, scale across, and chassis alternative. We touch it a little bit, but in multi-tenancy, the requirement is to have strong isolation between tenants and to have good load balancing between tenants, and do all of that without overhead. You can do that in other technology with some encapsulation, with virtual LANs, so different tunneling technology, but that will give you an overhead. It's a lot of penalty to pay in the throughput. So in FSC, you don't have that. That's very important in multi-tenancy, and this is the reason when customers are testing our technology, they are very happy when they have multiple tenants in the network. Unified fabric, we talked about it again, to unify the compute and the storage. Traditionally, when customers are talking about unifying the network in Ethernet, they told me, oh, it's complex because we need to manage it. We need to separate the different traffics. So that's in traditional Ethernet. You need to do a lot of configuration and a lot of efforts. In FSC, with the multiple VOQs, it comes out of the box, so it's on the other way around. It actually makes their life much simpler. Scale across, we talked about it. And again, other solutions are talking about having some kind of scale across, but the fact that we are using the Jericho IC with the HBM, this is the best way to make sure you're keeping the lossless functionality. You have HBM, you have buffering option. If the connection between the site is jittery, you are able to overcome it. If you have a software solution, you actually cannot overcome those bursts of traffic. So the best way to do it is with hardware, with HBM. And again, in our solution, we have it. In standard Ethernet or InfiniBand, they don't have this HBM solution. And also there is the chassis alternative. If somebody would like to do a massive scale, they want high radix switches. So DriveNets is known for disaggregation, meaning you can take the boxes and actually cluster them into a chassis-like solution. And this solution, you can see the DriveNets fabric schedule is not considered as an Ethernet hop. It's not. It's actually a cell-based network. So if you can still have a leaf and spine technology still with 2 hops and have massive scale of GPUs. So you can use a standard Tomahawk boxes, actually coming from Edgecore as well, and on top of them, the DriveNet solution that will look like a chassis. So you can use multiple clusters of those. So this is the chassis alternative. So if we look at the advantages, again, we talked about the performance, the multi-tenancy. What's new here is the openness. And I want to emphasize that when you're using DriveNets, you avoid vendor lock. You can use any GPU. You can have mix of GPUs. You can use different NICs, different optics. You can buy them yourself. You can ask DriveNets services to buy it from you. So we have our own relationship and our own inventory. But in the end of the day, you are not locked, and you can use whatever is available, whatever is certified in your organization. So this is very important, that this solution is, on top of all the benefits, it's open. So to summarize it, what DriveNets FSC is a mixture. It's best of both InfiniBand and Ethernet. From InfiniBand, we take the strong point of performance. We don't take the other limitation. From Ethernet, we take the scalability, we take the cost attractiveness of it, and the openness of it. And in the end of the day, DriveNets FSC provides you the best solution based on Ethernet. So this is the quote: the highest performance Ethernet fabric for AI workloads based on fabric schedule Ethernet with minimal time to first token. And again, DriveNets, we are not only a networking solution from AI, we are providing the full solution, full stack solution that includes the networking and also advanced tool for cluster management.